Hello everyone and welcome! Have you ever wondered how a computer can possibly predict something like whether a student will pass or fail a course? Well, in this session, we're going to build our very first machine learning model to do exactly that. We're going to strip away all the hype and see how it really works. Let's get started.
First off, a very warm welcome to all our partners at the Center for Data Archiving, Management, Analysis, and Advocacy in the Department of Data Science and Economic Policy right here at the University of Cape Coast. This is our 7th session, and it's also the final session of Phase 2 in our Foundational Knowledge program. And honestly, it's the perfect way to finish, because today, we're pulling everything we've learned together to build our first predictive model.
So here's our game plan. First, we're going to demystify machine learning. What is it actually doing? Then, we'll walk through a 7-step workflow to build our own model. We'll spend some real time on what I think is the most important concept, honest testing. After that, we'll figure out how to evaluate if our model is any good, talk about the crucial ethics of using these predictions, and finally, we'll take a quick peek at what's coming next.
All right, first up, learning from patterns, not magic. Let's tackle some of the biggest myths you've probably heard about AI and machine learning right off the bat.
You know, a lot of people imagine machine learning as this sort of magic, where the computer just starts thinking for itself. But the reality? It's way more practical. It's really all about structured pattern recognition. The computer is just looking for patterns in data, where we already know the outcome.
So here's the absolute core of it. Machine learning is a process. A model learns from examples we give it, like student records where we already know who passed and who failed. It then hunts for patterns connecting things like attendance or quiz scores to that result. And once it finds those patterns, it uses them to make a prediction for a new student it's never seen before. That's it. It's a tool for finding patterns, not a thinking machine.
Okay, so now let's get into the how. How does this all fit together into a logical, repeatable process? This is our 7-step practical workflow for building your very first model.
These are the 6 steps we're going to follow every time. We start by defining our goal. We call that the target. Then we choose our evidence, the features. We always inspect our data first. And then, and this is so important, we split our data for honest testing. Only then do we train the model, and at the very end, we evaluate how well it actually did. It's a really clear roadmap that takes us from a simple question to a carefully considered answer. For our example, we're going to use a simple, pretty intuitive data set. Just imagine we have a spreadsheet of student records. It's got their attendance percentage, how many hours they study, their quiz scores, and their assignment scores. And most importantly, we have their final result, pass or fail. This is the labeled data that our model is going to learn from.
Now, the very first thing we do is separate our data into 2 pieces. The features, which we usually call X, are all the inputs the model can use as evidence. Attendance, study hours, all that stuff. The target, which we call Y, is the one single thing we want to predict. In this case, the result. And look, the most critical rule for any beginner is right there on the slide. You must never, ever let the answer, the results column, be a part of your X data. That's like giving a student the answer key before the exam. It's completely useless. Okay, now we're at what I truly believe is the most important concept in this entire session, the principle of honest testing. If you only remember one thing today, please make it this.
It all boils down to this fundamental question. How can we be sure that our model has actually learned the general patterns instead of just memorizing the specific answers we showed it? Because there is a massive, massive difference between the two.
And this quote just says it all perfectly. Testing a model on the same data it was trained on is like giving a student the exact same questions they practiced with. Sure, it tells you if they can memorize, but it tells you nothing about whether they actually understand the subject. We have to test our model on new problems it has never seen before.
So how do we do that? Simple. We split our data. We use a function to basically hold back a chunk of our data. Here, it's 25%. And we call this our test set. The model will train on the other 75%, the training set, but it will never, ever get to see the test set during its training. The test set is the final exam for our model.
All right, the model's been trained. Now it's exam time. Let's see how our model actually did on that data we held back. It's time to find out, did our model actually learn anything useful?
So what we're going to do is train 2 different kinds of models on our training data. One is called a decision tree, the other is logistic regression. The big idea here is that there's no one best algorithm for every problem. Different models learn in different ways. Once they're trained, we're going to give them the test features, the X test data, and see how well their predictions match the real answers, the Y test data.
Now, when we evaluate the model, we can't just look at overall accuracy. I mean, accuracy is a good start.
It tells us what percentage of predictions were right, but we have to dig deeper. Take a look at precision for the fail class. That asks, of all the students we predicted would fail, how many of them actually did? This helps us avoid raising false alarms. But maybe even more important is recall. Recall asks, of all the students who truly did fail, how many did our model successfully catch?
And this is absolutely crucial. In a student support context like this, recall is almost always the most important number. Why? Well, think about it. The cost of missing a student who genuinely needs help is far, far greater than the cost of offering a little extra support to a student who might have been fine on their own. We'd much rather catch every single person who might be struggling.
And that brings us to what might be the most vital part of this whole discussion, how we actually use these predictions. This is where we move from just writing code to exercising our conscience. It's about understanding that a prediction is an estimate, not a final verdict.
Please, just let that sentence sink in for a moment. A predictive model gives us a data-based estimate. It's a suggestion based on patterns it saw in the past. It is never, ever a final, unchangeable judgment on a person's future.
And this right here shows exactly what that means in the real world. If our model flags a student as likely to fail, the right response is to start a conversation. It's a signal to offer support, maybe some mentorship or tutoring. The completely wrong response is to use that prediction to automatically punish someone, like kicking them out of a program. A prediction should always be a doorway to help, never a closed gate.
And we have to remember, the model only sees numbers. It can see a pattern between low attendance and failing, but it has no idea why that attendance is low. Is the student sick? Is there a family emergency? Are they having trouble with transportation? Only a human can understand that context. Human review isn't just a good idea, it is absolutely essential.
So as we wrap up Phase 2, let's think about how the good habits we've built, checking our data, testing honestly, interpreting results with caution, are going to prepare us for what's coming up next in Phase 3.
In Phase 3, we're going to dive headfirst into the world of generative AI. We'll explore these incredibly powerful tools like ChatGPT and Gemini, not as magic boxes, but as assistants for our academic work. And guess what? The same habits of verifying our sources and documenting our process that we've built here will be your most important skills for using these new tools responsibly.
So I'll leave you with this final thought. A prediction is never the end of the story. It's the beginning of one. If our little model flagged a real student right here at UCC as being at risk, what would be the first 3 questions you'd ask before you even thought about what to do next? Thank you.